Greetings and welcome to STEM Smart Academy. We're going to revise section 2 of this wonderful paper, that is the Kakamega Joint Examinations, end of term 1, 2026. If you missed looking at section 1, you can follow along in our comment section and you will be able to find it there. You can tell your other friends that the initial link I shared is no longer working, so you can reshare this link to them so that they might also join this wonderful session. So let's go straight to question number 16. We are going straight to question number 17, sorry. All the section 1 of this paper was well discussed in the previous video. You can just go and watch along. We are going to question number 17 of section B. A very, very wonderful paper. So hope you are tuned and you are ready. Hope you are tuned and you are ready. So share this link to your other friends, notify them about the change we've made. So on the grid below, draw a triangle ABC with vertices A, 1, 4, B, 4, 3, and C, 3, 2. That's one mark we need to do. We've been told to draw, so let's do the drawing together, ladies and gentlemen. Ladies and gentlemen, remember that in STEM Smart Academy, everything is normally simplified. So let's look at it. So let's draw. They are saying A is 1, 4. 1, 4. So 1, 4 is here. That's our A. B we have 4, 3. B we have 4, 3 here. That is our B. C we have 3, 2. 3, 2. That's our C. So it's a triangle we have to complete using a ruler. So we join A to B. You have to join A to B this way. B to C. C back to A. You can see what we've drawn is a triangle. After that drawing, the next statement says in part B, on the same grid draw A prime, B prime, C prime with A prime to negative 5. Let's locate it. Allow I use a different ink. To negative 5. To negative 5 is here. That is A prime. B prime 3, negative 2. 3, negative 2. 3, negative 2 is here. That is our B prime. C prime, we are having 4, negative 3. 4, negative 3 is here. That is C prime. So let's join and see. Let's join and see. I'm joining to form my triangle. I'm joining my points to form the new image. So when you join, that is what you're going to obtain. Then they are saying, after drawing, hence describe the transformation that maps ABC onto A prime, B prime, C prime. When you look at it, when you're told to describe the transformation, let's look at it well. This is a rotation. Maybe before we know it's a rotation, let's do this. Let me use a green pen. For I to identify this transformation, let me join the points. Let me join B to B prime. Allow I join B to B prime using a dotted line. After joining B to B prime, you need to bisect. You need to bisect this point, this line, sorry. And when you bisect the line, you might find the perpendicular bisector passing through such like a point. Then also join C to C prime this way. Then bisect. Upon bisecting, you find something like that. The two bisectors have intersected at point 60. So that point 60 becomes the center of rotation. So to describe this is a rotation about point 60, about point 60. But when you look at it well, when you look at this rotation well, it is a positive 240 degrees. Positive to 40 degrees. So this transformation is a rotation. The transformation here is a rotation about 60, that's the center of rotation, through, then you must give the angle of rotation through positive to 40 degrees. Through positive to 40 degrees. That is that transformation. But see, on the same grid draw A double prime, B double prime, C double prime, the image of A prime, B prime, C prime, and enlargement scale factor -2 about the center 1, -2. First of all, let's locate the center. Center 1, -2. Center 1, -2. 1, -2. This is the center. So join A. If you want to locate it well, I join A through that. And because it is double, so A prime, my A prime now will be going up to the top there. That will be now my A double prime. This point, that is the point. Let me use which pen now? Let me maybe use this. This is the point that now we call, that one is not visible. Let me use this. A double prime. Again, let's locate B. We are going again to join B. So with B, -2 because there are 2 units, so that will be 1, 2, 3, 4. So with this, with the B triple prime, it's here, the B double prime. I now need to get the C double prime. My C double prime can be obtained this way. Let me join from C prime through the center of enlargement to the opposite side, that way. So this point here is our C double prime. So let's join B double prime to C double prime to A double prime 2. We are doing the joining that way. We've done the drawing. Then they are saying state the coordinates of A double prime, B double prime, C double prime. So the coordinates of A double prime in this case, we have negative 1, 4, negative 1, 4. The coordinates of B double prime, we have negative 3, negative 2, negative 3, negative 2, negative 3, negative 2. And the coordinates of C double prime, we have negative 4, 0, negative 4, 0. So that's how you do that question to get those marks. State the type of congruence that exists between A prime, B prime, C prime, and its image A double prime. When you look at that, because it's an enlargement, then an enlargement is under what is called a direct congruence. So the type of congruence here is called direct congruence. It's a direct congruence because it is an enlargement. So an enlargement is basically a direct congruence. So you can see we have the marks. Let's have a look at question number 18. Sorry, we are having a look at question number 18. Don't forget subscribing. Drop that comment and share this link to your other friends if you are a first timer to STEM Smart Academy. Share this link to your other friends. Thank you to those who are following. Thank you, thank you, thank you. The coordinates of P and Q are negative 2, 3 and 1, 3 respectively. A point T divides the line PQ in the ratio 2:1. Determine the coordinates of the point T. So, with this question, it's very important to give a sketch so that you get to understand what is required of you. We have 2 points, P and Q. Allow I can join them to the origin here, O. So we have a point T that divides in the ratio 2:1, meaning this will be 2/3, 1/3. That way, to get the coordinates of the point T, I'm going to use the ratio theorem. The ratio theorem says to get the coordinates of T, I'm now going to have a third P plus 2/3 Q. That's how you get the coordinates of T. So that means we are going to have a third of P. P is negative 2, 3 plus 2/3 plus 2/3 of Q, which is a third. Not a third, but which is 1/1, 3. So let's open the brackets. When you open the brackets, this is going to give you negative 2/3, negative 2/3, 1, plus 2/3, 1. When you do that, negative 2/3 plus 2/3, that will give you a 0. 1 plus 1. So this should be 2 here, because 2/3 times 3, that will be 2. So 1 plus 2, that will be 3. So T is 0, 3, but now because they want it in coordinate form, so the coordinate of T is 0, 0, 3. That's how you get the 3 marks there. Roman 2, find the values of M and N, given that MPQ minus NQ is equal to negative 12, 9. So MP, remember our P is negative 2, 3. So M into negative 2, 3 minus N into Q. Q is 1, 3. this should be equivalent to negative 12, 9. So here, m times negative 2, that will be negative 2m. M times 3, that's going to be, just a moment, let me see. Here you need to be very, very keen. 3m, then minus n, then 3n should be equivalent to negative 12, 9. So here we are going to get two equations. We are going to get two equations here. The first equation we are going to have, when you look at the equation well, the first equation we are going to have is the upper one. That is a negative 2m negative 2m. Let me see. The value of q, okay. Negative 2m minus n is equivalent to negative 12. Then the next case we are having 3m minus 3n is equal to 9. So we have to solve these two simultaneously. I can eliminate m by multiplying here by 3, here by 2. So that will be negative 6m minus 3n being equal to negative 36. Then 6m minus 6n being equal to 18. To eliminate m here, we are going to do addition. Once you do addition, m will cancel. Negative 3n plus negative 6n, that will be negative 9n being equivalent to negative 36 plus 18, that's going to be negative 18. In that context, if you have negative 9n is equal to negative 18, then it will mean the value of n is going to be equal to 2. And if n is 2, to get m, we're going to have 3m minus 3 into n, which is 2, should give me 9. So this will be 3m minus 6 is equals to 9. It will mean that our 3m here will be equivalent to 9 plus 6. So 3m is equals to 15. That means the value of m will be equivalent to 5. So m is 5, n is 2. That is how you interpret such like a question. Let's proceed to the next question. That's part B of the very question. Find Roman 1 q prime, the image of q, under the same translation vector that mapped p onto p prime, which is 10, 10. So we have vector p. Let me see. P was negative 2, 3. Remember, when I take the object p plus the translation vector, I should get the image p prime. So the object of p is negative 2, 3. So I'm going to have here negative 2, 3 plus the translation vector, which I don't know. This should give me the p prime, which is 10, 10. So that means to get what is called the translation vector, you are going to have 10, 10 minus negative 2, 3. And this will give you 10 minus negative 2, that should be 12. 10 minus 3, that is 7. So the translation vector is 12, 7. After getting the translation vector now, they want the image of the image Q prime of Q. What I know, when you take Q plus the translation vector, it should give you the image Q prime. So our Q in this context, learners, our Q, we had been told it is 1, 3. So we are going to do substitution here. 1, 3 plus the translation vector 12, 7. This should give you the image Q prime. 1 plus 3, that is going to be 13. 3 plus 7, that's going to be 10. Should be equal to Q prime. So find Q prime, the image of this. So that means our Q prime is 13, 10. Our Q prime is 13, 10. Or you can write it in coordinate form and say that our Q prime is 13, 10. 13, 10. Let's look at this. The magnitude of a half P minus Q. So first of all, let's solve this. When you've been told a half P minus Q, this means it's a half of P. Remember, our P was negative 2, 3 minus Q, and our Q is 1, 3. So this means a half times negative 1, negative 2, that's going to be negative 1. Then this will be 3 over 2 minus 1, 3. So negative 1 minus 1, that's going to be negative 2. Then when you have 3 over 2, 3 over 2 minus 3, that is giving you negative 1.5. Negative 1.5. But now when they talk about the magnitude, so the magnitude of a half P minus Q, this should be bars. The bars here show that it's magnitude. This is the square root of negative 2 squared plus negative 1.5 squared. All of this is under the square root symbol. All of this is under the square root symbol. So this is going to give you, when you take negative 2 squared plus negative 1.5 squared, and you get its square root, that's going to give you 2.5. That's going to give you 2.5. But because the question wants your answer to 2dp, so to 2dp, your answer should be 2.50 units. Make sure you leave your answer correct to 2dp as per the requirements of that particular question. Don't forget to subscribe, like, and share these videos with your other friends. We proceed to question number next. That is our question in form to work. Two lines, L1 and L2, are parallel. L3 is perpendicular to both L1 and L2. Part A of the question, Roman 1 of it. Line L1 passes through point A, that is negative 3, 6, and B, 3, 9. Find the gradient of L2. Find the gradient of L2. The question is very simple. Remember, they are saying that L1 and L2 are parallel. So if the two are parallel, first of all, let's get the gradient of line L1 before we get the gradient of L2. So to get the gradient of L1, which I can call M of L1, Remember, gradient is change in y over change in x. So it will be 9 minus 6 over change in x, which is given by 3 minus negative 3. So 9 minus 6, that is going to be 3, over 3 minus negative 3, that is 6. So this simplifies the gradient of line L1 to a half. Now, because they say that L1 and L2 are parallel, remember, for parallel lines, their gradients are the same. So the gradient of line L2 should be equal to the gradient of line L1, which should be equivalent to a half. Because they are parallel, you must always know that for parallel lines, their gradients are the same. L3 is perpendicular to both L2 and L1. So what is the question asking? The gradient of L2. So the gradient of L2 here, the answer is also a half, because the two share the same gradient because they are parallel. Roman 2 of the same question. Line L2 intersects the x-axis at point C, negative 5, 0. Determine the equation of L2. So, because we know that the gradient of L2 is a half, and it is passing through this point negative 5, 0, I'll form another point which I'll call xy. So in this context now, I'm going to have y minus 0 over x minus negative 5. This should give you the gradient, which is a half. When you cross multiply, this will mean that y minus 0 is equal to a half into x plus 5. So once you have this, it means y minus 0 is y. So we are going to have this as y being equal to a half x plus 2.5. A half x plus 2.5. But now, when you look at it, they want in the form of ax plus by. Maybe let me change this 2.5. Just let me use it as 5 over 2. Let me maintain it as 5 over 2. But now, because they want it in the form of ax plus by is equals to c. So ax, that means when we have to write it in that manner, our ax, that will be now negative a half x plus y should be equals to 5 over 2. But now, because this c should be a constant, when you look at here, we have 5 over 2, which is not constant. We can remove the denominator by multiplying each part by the LCM, which is 2. So you multiply here by 2, by 2, by 2. So 2 times a half x, this will mean this will be negative x plus now y times 2, that will be 2y, should be equal to 5 over 2 times 2, that should be equivalent to 5. So that is the answer. Negative a half x plus 2y is equal to 5. You have to ensure that the constant on the right hand side of the equal sign is an integer and not once again a whole number. So it's an integer and not a decimal number or a fraction part. Let's look at part B of the very question. Part B of a very, very wonderful question paper here. You can see what we are bringing to you, so don't forget subscribing. Line L3 intersects line L1 and L2 at point A, negative 3, 6, and P respectively. So they say that L3 intersects line L1 and L2 at point A, negative 3, 6, and P respectively. Roman 1, determine the equation of L3 in the form of x over A plus y over b is equal to 1. That form is what is normally called the double intercept form. The double intercept form. So the secret here is, one, we need to get the gradient of L3. When you revisit the top here, they say that L3 is perpendicular to both L1 and L2. So what you need to know here is that when I take the gradient of line L1 times the gradient of line L3, the product should give me -1. The product of line 1 is a half. So that means when I take a half times the product of line L3, I get -1. Therefore, that means the gradient of line L3 is -2. That is the gradient of line L3. After getting the gradient of line L3, because now it intersects line L1 at this point, then it means when I take the point -36, I introduce another point xy. With now our new gradient, we are able to get the equation. So this will be now y minus 6 all over x minus -3. This should be equal to the new gradient, which is -2. So this will be now y minus 6 is equal to -2 into x plus 3. Remember, x minus -3 is just like saying x plus 3. So this will be now y minus 6 should be equals to -2x minus 6. -2x minus 6. So let's recorrect. When I move -2x to the left, it will become positive. So that will be now 2x plus y is equal to -6 plus 6. So that means that 2x plus y will be equal to 0. But now because we are having it that way, are we done? They want it in the form of x over a plus y over b being equivalent to 1. So in the double intercept form, in the double intercept form, we are going to divide through by 2. Sorry, when you have it this way, when you want now to write it in the double intercept form, we are trying to see. So this one will just have to remain this way in that context. Roman 2, determine now the coordinates of P. We are now supposed to determine the coordinates of P. Now remember that L3 intersects with L2 at P. To find the intersectory point, because we have the equation of L3, and at the top here, this was the equation of L2, we can solve them simultaneously. We can take the equation of L2, that is -x plus 2y is equals to 5. I'm having -x plus 2y being equivalent to 5. Then this is 2x plus y is equal to 0. I can eliminate y by simply multiplying here by 1, this by 2. So the upper equation will just remain as -x plus 2y being equal to 5. Then the lower equation now here, sorry for that, the lower equation here will now become 4x plus 2y is equal to 0. Then you can eliminate the y by doing subtraction. So when you do the subtraction, -x minus 4x, that is going to be now -5x. Then 2y minus 2y, that will be 0. So this one should be equal to 5 minus 0, 5. So that will mean the value of x here is going to be equal to -1. The value of x is equal to -1. After getting the value of x as -1, to get the value of y, we are going to replace to any of the equation. Allow a replace to the lower equation, that is 2x. So that will be now 2 into -1 plus y to give me a 0. To give me a 0. So this means that -2 plus y is equals to 0. So when you have -2 plus y is equals to 0, that will mean that y will be equal to 2. The value of y will be equal to 2. And after getting that, then it means now that the coordinates of P are -1, 2. The coordinates of P are -1, 2. And that's how you get 10 marks. That's how you get 10 marks. Don't forget to subscribe, like, and share these videos with your other friends. You can also drop a comment in the chat section telling us where you are following us live from and how you are understanding this simplified mathematics. Let's have a look at question number 20, ladies and gentlemen. Share this link to your other friends. Remember, these papers are of standard quality and very important to a serious candidate or someone who wants to improve in mathematics. Let's have a discussion on question number 20. The diagram below shows a speed time graph of a moving car in 12 seconds. So when you look at the question keenly, it's a velocity time graph. State the maximum speed attained by the car in kilometers per hour. We are told to state the maximum speed attained by the car in kilometers per hour. When you look at the maximum speed attained, it is 75. So it is 75, but that 75 is in meters per second, but the question now wants the answer in kilometers per hour. So how do you convert this 75 to kilometers per hour? You simply take 18 over 5 times 75. So by the help of your calculator, when you take 18 over 5 times 75, you are going to get 270 kilometers per hour. 270 kilometers per hour as the answer for part A of this wonderful question. 270 kilometers per hour. That's how you get the 2 marks. Part B, Roman 1, the deceleration of the car. The car was decelerating from the time when t is equals to 9 to t is equals to 12. That's what you need to understand. So for you to compute the deceleration of the car, you're going to take final velocity v minus u over t. So this means the final velocity is when it came to rest, that is 0, minus initial velocity when it began decelerating when the velocity was 75. So that is minus 75 over the change in time, which is given by 12 minus 9. So when you work on that, this is negative 75 over 3, which is like saying negative 25 meters per square second. But now, learners, there is one thing I want to elaborate. When they say, remember this is acceleration. I've been calculating acceleration. But now the question wants the deceleration. When they talk about the term deceleration, already it means it is decelerating. So the answer, you leave it as a positive value of 25 meters per square seconds. 25, it must be positive answer. 25 meters per square seconds. Let's look at Roman 2 of the very question, where we are being told that the distance covered by the whole journey. So to compute the distance covered by the whole journey, remember, for us to work it out, we need to calculate the velocity, the area under the graph. The area under this graph is going to give us the distance covered. So the first part I'm going to do, I'm going to calculate the area of the trapezium part. If I shade this part is the first trapezium. You can calculate its area. Remember, area of a trapezium is a half into A plus BH. So that means we are going to have it as a half into A plus BH. A and B are the parallel lines. That is 8 plus 5. If from here to here is 8, then from here to here is 5. Because 8 minus 3 is 5. So we have that, and the value here is 30. So 8 plus 5 into 30. 8 plus 5, then you multiply that by 30. That's going to give you that. Plus, we have another shape. In this context, we have another trapezium. Let me indicate it using a black X. This one also is a trapezium on its own. So we can compute its area, the one I've indicated with X's. So with that one, the a half into A, the first A will be 75, the next one will be 30, then the height will be 1. So that's going to be a half into 75 plus 30 multiplied by 1. Then now plus, we have another remaining figure. The figure now that's remaining is a triangle. This one here is a triangle. Area is a half times base times height. So a half, from 9 to 12, the base here will be 3, and the height will be 75. So that will be now a half times the base 3 multiplied by the height of 75. We are multiplying by the height of 75. So let's do this computation. So this means this will be 45. Sorry. Let me be very keen here. A half into A plus BH. So that will be a half multiplied by 13 multiplied by 30. That's 195. This is a 195 plus a half multiplied by 75 plus 30, that's 105, times 1, that is 52.5. Then plus a half by 3 by 75, that is 112.5. When you sum all this, ladies and gentlemen, let's add all of this using our calculators. This gives you 360 meters as the total distance for the whole journey. 360 meters. Part C, calculate the time taken to travel the first half of the journey. So if the total journey is 360 meters, so the first half journey, this means it is 360 divided by 2, which is equivalent to 180 meters. That is the first half of the journey. Now, when you look at that, The first half of the journey, 180 meters, is the distance within the first triangle, the first trapezium. So for instance, let's assume the first half is here. And because I don't know that value, I can say let the value here be, let from here to here be k, for example. Then from here to here, because already this is 3, so from here to here it will be k minus 3, and the height remains. So we are going to apply the formula that distance, which is now 180 here, should be given by a half into a. Our a, we've said the first a will be k, plus b, which will be k minus 3, times h. Our height here from the question is 30. So you multiply that by 30. You multiply this by 30. So this will be now 180 is equal to 2k minus 3 into 15. So that will be now 180 is equal to 2k times 15, that is going to be 30k. Negative 3 times 15, that's going to be negative 45. So 30k here will be equal to, when you take 180 plus 45, that is 225. You divide through by 30. Therefore, you're going to get the value of k as 7.5. 7.5. 7.5. Remember, that k is the time taken to cover the first half of the journey. So the correct answer here should be 7.5 seconds. 7.5 seconds as the answer to that question. Subscribe, like, and share this video with your other friends. Let's look at question number 21. Question number 21. That the bearing, 4 towns A, B, C, and D are such that B is 84 kilometers from A on a bearing of 63 degrees. C is 120 kilometers on a bearing of south 30 degrees east from B and 80 degrees from D, while D is due south of B. Using a scale of 1 centimeter to represent 10 kilometers, draw a diagram to show the relative positions of towns. Draw a diagram to show the relative positions of towns. So with this question, ladies and gentlemen, we are going to do analysis of one by one. I'll be giving you clear guidance, though I'll be using a sketch because I don't have the construction tools. So let's reread the question. 4 towns A, B, C, and D are such that B is 84 kilometers from A and on a bearing of 63 degrees. So that means I have my town A here. I have this as my town A. This is my town A. On a bearing of 63 degrees from the North Pole in the clockwise direction, we are going to have B. we are going to have B. We are going to have B. So this is our town B, 84 kilometers, and they ensure the angle from the north in that direction is 63 degrees. That's how you locate B. Now, because make sure you use this scale. So 84 kilometers, that is just like saying 8.4 centimeters. After locating B, C is 120 kilometers on a bearing of south 30 degrees east from B. So south 30 degrees east from B. So that means you need to be very, very keen here. South 30 degrees. So what this means is that from the southern side, when you go to the eastern side that way, this angle here should be 30 degrees. But 120 kilometers is just like saying 12 centimeters. 12 centimeters. So at that particular juncture, you locate your town C. This is my town C. Then they say, and 80 degrees from D. When they say 80 degrees from D, that is now where the tree comes from. While D is due south of B. Now let's analyze this. 80 degrees from D. Remember the concept of alternate angles. For example, if B is 63 degrees from A, if this angle is 63, this one also here is 63 because they are alternating angles. Now I want we use that property to analyze this. When they say it is 80 degrees from D, it means even D can be located this way. If you want to locate D here, I know this is the tricky part. D will be located in such like a manner, but now you have to ensure that this angle here is 80 degrees. And the same D, they are saying it is due south of B. So from B, due south of B that way. So the intersectory point here, learners, become your D. That is now our D. After locating our D, we have another point we don't have. So the question is, find the distance, from the diagram, find the distance AC. So my AC is 15 centimeters. So I'm going to take 15 centimeters times 10. This gives me 150 kilometers as the answer for AC. Remember the first step I've done? I've joined A to C, then I've measured it, and I've converted using my scale. Part Roman 2 of the question, the bearing of A from D. So when you're told to get the bearing of A from D, join first A to D. Let's join A to D. We are joining A to D that way. The bearing of A from D is this angle here. So you measure from the North Pole in the clockwise direction. That angle there you get it is 315 degrees. 315 degrees. Roman 3, the compass bearing of A from C. The compass bearing of A from C. A from C, A from C. And they are very particular here. They want the compass bearing. So when you look at A from C, one, A is to the northern side of C and also to the western side. So that is north, 63 degrees west. They are very particular here. They want the compass bearing, not the true bearing, or just not any bearing. So the correct answer here should be north, 63 degrees west. North, 63 degrees west. Roman 4, the question, the distance DC. Let's see the distance DC. You measure using a pair of divider, you get 6.1 centimeters. Then the 6.1 centimeters, you multiply by the 10. So this becomes 61 kilometers. 61 kilometers, ladies and gentlemen. That's how you analyze these mathematics questions and you enjoy working it out. Someone is asking, which class is this for, sir? This is Form 4 Mathematics and 844. So let's keep subscribing and inviting our other friends to this wonderful session. We are now going to the most interesting bit of angle properties. Let's look at the question. The following figure shows a quadrilateral PQRS and a circle passing through the vertices P, Q, R, and S. Sorry, P, R, and S. Lines PQ is equal to PR is equal to 2.7. PS is equals to 6. SR is equals to 7. And angle PQR is equals to 65 degrees. Calculate Roman 1, the length QR. Let's see. The length QR, that's very simple. When they talk about QR, this one even you can use what is called the Pythagoras, not the sine rule. Let me draw it here. Q, PR, this is 65, 2.7, 2.7. They want the length QR, this length here. QR, this one you have to apply. You must use here the sine rule, the cosine rule. That can be quite easier. But we can even apply the sine rule. The sine rule here will be 2.7 over sine 65 should be equal to, look at this, because PQ is equal to PR, then it means this triangle is an isosceles triangle. And an isosceles triangle has the base angles equal. So if this is 65, this one also here should be 65. So 2.7 over sine 6.5 will be now equal to, first I need to get this angle. Let me compute angle QPR, which will be now 180 minus 65 plus 65. So 65 plus 65 is 130, from 180 that is 50. So the angle at the top here is 50. So this is like saying QR over sine 50 over sine 50. So to get QR, to compute QR, we are going to have sine 50 being multiplied by 2.7 all over sine 65. And this is going to give you 2.282. This is giving 2.282 centimeters. Roman 2, angle P I can have that as a squared. I can use the formula a squared is equals to b squared plus c squared minus 2bc cos a. So my a squared here will be 6 squared. 6 squared is equals to b squared plus c squared. That is 7 plus 7 and 2.7. So this will be 7 squared plus 2.7 squared minus 2 times b, which is 7, times c, which is 2.7, cos a. So this is 36 is equivalent to 7 squared, 7 squared plus 2.7 squared, that is 56.59, minus 2 times 7 times 2.7, that is 37.8. 37.8 cos A. So when you are here, you collect the like terms, you are going to have these as 37.8 cos A being equivalent to 56.59, you minus 36. So that is 37.8 cos A being equal to 56.59, you minus 36, that becomes 20.59. So this means that cos 20.59 of 37.8. So let me get the cos inverse. So that means it is 56.995 degrees. 56.995 degrees. I hope I've done that computation well. Let's have a look at the next part. Determine the area of the shaded part. Let's look at the shaded part. The area of the shaded part, let's see. We want to determine the area of the shaded part. So, first of all, I'm trying to see the better way of tackling that. How do you get the area of that shaded part? How do you get the area of that shaded part? So, the area of the shaded part. So first, let us see what we can do here. So we've already found this angle here. the angle at R as 56, sorry, the angle at R as 56.995. This one here, 56.995. After getting that angle, I want you to bear this in mind, that 6 over sine, yes, I want to apply that, 6 over sine 56.995 should be equal to 7 over sine p. So that means that sine p will be equal to 7 sine 56.995 divided by 6. So that will mean that this is like saying 0.9503. Then to get p, the angle at p, we are going to get the sine inverse of 0.9503. So the angle at P is 71.86 degrees. This angle here, 71.86 degrees. So after getting that, so we've gotten that. The next thing now we need to understand is that after getting that, let's get out the angle in between. Remember that the best way for you to work out this question you should be able to calculate the area of for you to calculate the area of this shaded part of the question, it should be the area of that sector minus the area of the rectangle, sorry, minus the area of the triangle. So this means that our angle here will be 143.72 degrees. And once we have that as our angle, we can now say, remember the formula that said that A over sine A to be equal to 2R under the sine rule. So this means that 6 over sine 56.995 is equals to 2R. Therefore, the radius here, the radius for our circle will be 6 divided by sine 56.995 divided by 2. So the radius is 3.578. 3.5 3.577 centimeters. After we've done that computation, after we've done the computation for the radius, now to get the shaded area, we are going to take the area of the sector, which is now 173. So not 173, sorry. This is 143.72 over 360. You make the area of the triangle, which is a half AB sine theta. So a half times A 3.577 squared. Sine the angle in between is 143.72 degrees. So when you compute this, let me key in all of these in a calculator once to save on time. 143.72 over 360 being multiplied by 3.142 times 3.577 squared, then minus a half times 3.577 squared sine 143.72. That is 12.26. 12.26 square centimeters as your answer for that question. A very, very interesting question. Let's proceed to question number 23, which is our second last question of discussion. The examination marks in a mathematics test for 60 students were as follows. You can see the marks. Then you're being told you've been given a table to complete the class, the tally, and the frequencies. So first of all, let's fill this table. So from 10 to 29, the tally here, 10 to 29. Let us see. 10 to 29. 10 to 29. 1, 2, 3, 4, 5, 6, 7, 8. They are 8 in number, so that will be the tally. How do you write the tally? 1, 2, 3, 4, 5, 6, 7, 8. So the frequency there is 8. 30 to 39. 30 to 39, there are 6, so that is 1, 2, 3, 4, 5. Sorry, it should be like this. Yeah, maybe even that can work. Yes, so this is 6. 40 to 69, there are 28. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 2, 3, 4, 5. Then 1, 2, 3. So this is 28. 70 to 74, there are 6. 1, 2, 3, 4, 5, 6. 75 to 89, 7. That's 1, 2, 3, 4, 5, 6, 7. Then finally 90 to 99, 5. 1, 2, 3, 4, 5. We are done with that part. So the total frequency here, when you add it, adds up to 60. State the model class. When you're stating the model class, you just look at the class with the highest frequency. So here, the class with the highest frequency learners is 40 to 69. 40 to 69. Part B, calculate the mean mark. So that means you need to get a column here for X. That is 19 point. X is 10 plus 29 divided by 2, 19.5. 30 plus 39 divided by 2, 34.5. 40 plus 69 divided by 2, 54.5. 70 plus 74 divided by 2, 72. 75 plus 89 divided by 2, 82. 90 plus 99 divided by 2, 94.5. So after that, you need to populate another column here for fx. 8 times 19.5, that is 156. 8 times 34.5, that is 207. Be very keen. Remember, statistics needs high level of keenness. 28 times 54.5, that is 1526. 6 times 72, that is 432. 7 times 82, 574. 5 times 94.5, that is 472.5. When you add here, you get a summation of 3367.5. So now we can calculate the mean. You say that mean x bar is given by summation of fx over summation of f. Summation of fx, that is 3367.5 divided by 60. So this gives you 56. You're going to get here 56.125. 56.125. Part C, on the grid below, draw a histogram to represent the above information. So before you draw your histogram, when you look at the question we have, when you look at such, what comes into your mind is that first let's look at the class intervals. The class intervals are not the same, so that means we need to populate what is called the frequency density. And to get the frequency density, this is given by the frequency over the class width. That's the formula. For example, this will be 8 divided by 8. The frequency density here will be 1. Sorry, not really. The frequency here is 8 divided by the class interval of 10. That will be 0.8. Then 6 divided by 10, 0.6. Then, that is like 69.5 minus 39.5. That is a class interval of 30. So frequency is 28 divided by the class interval. That gives you 28 divided by 30. That is 0.9. Then 6 divided by 5. That's 1.2. 7 divided by 7 divided by another, this one also should be 5. So no, this is let me see, 89.5 minus 74.5, that is 15. So 7 divided by 15, that is 0.67. So 0.46. No, 47. Then 5 divided by 10, that is 0.5. Like that. After realizing like that, the next step we are going to do here is the next step to be done is a very simple step. When you look at your values, they go all the way up to, the maximum is 1.2. The maximum is 1.2. So choice of a suitable scale. Let me guide you here. Remember, math is fun. You need confidence. You also need individual practice for you to get the very best results. But generally, math is a very, very simple subject. So on the y-axis, we are going to plot the frequency density. On the x-axis, we are going to place the class boundaries. So because the frequency density goes all the way to 1.2, let me see, 0. Let me go with this as 0.2, 0.4, 0.6, 0.8, 1.0, 1.2. That's better. Then we have 9.5. I want to start with 9.5 here. Then we go to 29.5. 29.5. 39, 49, 59, 69, 79. This goes all the way to 99. So I have to reduce my spacing. Let me go with this as the interval. 29.5, 39.5, 49.5, 59.5, 69.5, 79.5, 89.5, 99.5. So we do. I began with the lowest, that's 9.5 to 29.5. The frequency density is 0.8. 0.8. So allow I draw the 0.8 here. The next is from 29 from 30 to 39. From 30 to 39. So the frequency density there is 0.6. 0.6. 0.6 is here, that way. Then after that, from that we are going to move 40 to 69.5. The frequency density there should be 0.9 to 69.5. The frequency density should be 0.9. Like this. Yes. Then after that, we're done with 69. 70 to 74.5. This time goes to 74.5. The frequency there is 1.2. The frequency there is 1.2. 1.2. Then after that, we have 75 to 89.5. The frequency there is almost 0.5. To 89, 0.5. Like that. Then from 90 to 99, the frequency is 0.5. 0.5. So this is how you draw your histograms, dear learners. This is how you draw your histograms. That is how your histogram should look like. That is how your histogram looks like. Use the above histogram to estimate the median mark by drawing a vertical line. Estimating a median mark. Now to estimate the median mark, because the total frequency is 60, so the median lies in the 30th position. Half of the frequency, half of 60, that is 30. So we are going to calculate the areas of each. So 30 should be equal to, have in the first bar, the frequency is 8. In the second bar is 6, that is 14 plus. The third bar is the biggest, and because we don't know, we can say with this one here, to calculate its area, I'm having that as 0.9 being multiplied by a certain value, maybe k. So this will be now 30 will now be equal to 14 plus 0.9k. So 16 will be equal to 0.9k. So the value of k in this context will be, when you take 16, you divide by 0.9, that is 17.78. 17.78. This 17.78, now to get the median mark, we were at the 39. So you have to take 39.5 plus 17.78. So when you take 39.5 plus 17.78, you get 57.28. 57.28. So after getting 57.28, you now need to look at where is it. 57.28. So this one I was moving with intervals of 10. So each is 2. So if this is 49, 50, it is somewhere here. 57.28 is somewhere here. That is a vertical line. That is the vertical line that shows the position of the median in that question. And that's how you respond to that simple question, ladies and gentlemen. Let's look at the last part of this question. In the figure below, QOT is a diameter and angle QTP is 48 degrees, TQR is 76, TQR 76, and angle SRT is 37 degrees. Calculate giving reasons in each case. Here we are just supposed to fill these angles. So first let's see. It is going to be very simple. If QOT is the diameter, the angle subtended by the diameter, the circumference is 90. So this angle is 90. Therefore, angle QTR will be 90 plus 76. In fact, I have 90 plus 76 minus from 180. This should be 14 degrees. 14 degrees. Let me see which side they want. RST. RST. Let me join RST here. That is when you look at it well, here you need to be very, very clinical. RST. RST. So, code is the alternate segment. We are trying to look at it. Where is the 48? 48, if 48 is here, let me get this angle here. 90 plus 48, that is 138. I'm saying 90 plus 48. You minus 180. This is 42. And if that angle is 42, I have to get this angle here. And to get that angle, it is very simple. Remember, when you look at QRST, it's a quadrilateral. Opposite angles of a cyclic quadrilateral. So this one here should be 180 minus 76. This is 104. So let's see. Calculate this should be 104 degrees. Then the reason is sum of opposite angles of a cyclic quadrilateral. Sum of opposite angles of a cyclic quadrilateral add up to 180 degrees. SUT, let's see, SUT, the one now this angle here. If this is 104, then this angle here should be 76. And if that angle is 76, this is 37,104. I can get this angle. To get angle R, RTS, it will be 180 minus 37 plus 104. So when you take 37 plus 104, you minus 180, that angle is 39. So this angle here is 39. So to get this angle here, to get angle STU, it will be 180 minus 48 plus 14 plus 39. So 48 plus 14 plus 39, 180 minus that should be 79. So this one here should be 79 degrees. After getting that, I can now get this, because to get now angle SUT, it's a triangle, so it will be again 180 minus 79 plus 76. This becomes 25 degrees. So that angle there is 25 degrees. You can say the reason here, angles in a triangle add up to 180 degrees. Next, obtuse ROT. ROT. Let me join ROT. This angle here. So to obtain that angle, because to obtain that angle, what you need to understand here is that RO is equals to OT, because they are radius. So if this angle is 14, this angle here is also 14. So to get angle ROT, it will be 180 minus 14 plus 14. That is just like saying 180 minus 28, that is 152. So the obtuse angle they are asking is 152 degrees. 152 degrees. The reason is angles of a triangle add up to 180 degrees. Then angle PST, let's look at PST now. PST, let me join. Let me use a blue ink because this one has filled a lot of space. PST, I join P to S. PST, they want now this angle here. That should be 42 degrees. angles subtended by the same chord PT. PT subtends angle at Q, also angle at S. So that angle should be 42 degrees. So I'm going to say this is 42 degrees. And the justification I'm going here to say is that angles subtended by the same chord. Angles subtended by the same chord are always equal. Then the reflex SOP. Let me look at now that SOP. Let's look at that SOP, the reflex. So let's join these points. SOP. I join P to O, also S to O. So they're asking about this angle here. Remember, okay, I'm trying just to see how best we can respond to that. So for us to get that angle, first of all, you have to understand that a half of POS, a half of angle POS should be equal to P let me see. Yes, should be equal to PTS. Angles subtended by the same chord in the alternate segment are normally equal. So that means that a half of POS, half of angle POS will be equal to 14 plus 48 plus 39. That is, let me see, 48 plus 14 plus 39. That is 101 degrees. Remember the property that says angle at the center is twice the angle at the circumference. So if I have POS equals to 101, then angle POS will be equals to 202 degrees. Because we have now 101 times 2. The question wants the reflex. The reflex. So that means that the angle here, we are going now to have remember this 202 is the angle POS. This angle. Its reflex now will become 360 minus 202. degrees. So the reflex SOP, this is now going to become 158 degrees. 158 degrees. The reason is angles at a point add up to 360 degrees. Angles at a point add up to 360 degrees. So that's what you are supposed to do in this paper to have scored everything in section B. Thank you for watching. Don't forget to subscribe, like, and share these videos with your other